Welcome to all. I am Muralidar Dhakshanamurthi. I am working as an assistant professor from the Department of Electronics and Communication Engineering, and also I am design to product lab in charge from JJ College of Engineering and Technology. So today I am going to take the topic Introduction to Embedded System and Arduino Uno. First thing is we need to know about what is the embedded system. So generally the embedded system, when we take it out, so the embedded system means it is a dedicated computer which can able to perform a specific task in a larger device. That is what we call it out as a embedded system, right? So why they matter in the sense actually they can be able to provide intelligence to any particular machines. For example, if you take it out like a washing machine. So washing machine, has some embedded systems is there. Like whatever in that washing machine, we are having like a rinse, wash, like that we are having dryers, like that we are having. That is the intelligent part that is being available in the larger devices. That is the embedded system. So in this system, will be having like microcontrollers, sensors, actuators, memory, all these things will be together. We will be having a forming out as a embedded systems. So in what way they can able to differ from other systems in the sense here it is being particularly been used for particular task. So for example, as I mentioned it out, as far as a washing machine is concerned, so it is going to perform a particular task like rinse, dry, like that it is going to perform, right? So it is going to be optimized for speed and it will be having a power efficiency and as well as the reliability will be there when compared to general systems. That is the thing we are been making it out as an embedded systems. So embedded system is nothing but a controller which will be specific task. That is called as a embedded systems. So here, if I take it out with this embedded systems, we will be making use of it for different applications. For example, smartphones. In smartphones, we will be making use of different things. For example, in smartphones, we will be having a camera will be there. We will be having some other sensors will be there. So it can able to perform multiple tasks like locations. It can able to do it. So here in that smartphones, we will be having different sensors, and each sensor is being take the inputs from the outside world and it can be able to perform some activities. So for that will be program will be there in that smartphones. The same way if you take it out like in automotive engineering. So for example, if you take a car, that car may have more than 50 plus ECUs will be there. ECUs nothing but electronic control units will be there. So when they need to communicate, for example, airbag, that is airbag system is there, anti-lock braking system will be there. So these and all different electronics control units will be there. For that each one will be performing. So we call it out as an embedded system. So if they want to communicate with each ECUs, we will be making use of protocols like CAN, LIN, like that, control area network, local interconnect network, like that. Some protocols will be making use of it. So each ECUs will be performing a particular task. This is what we call it out as a embedded systems. When coming to the medical devices, so we can able to use it out in your pacemakers, insulin pumps and MRI machines. Each one is having their own unique task to be done by the particular devices. So as far as the home appliances is concerned, so we'll be having like a microwave oven, as I mentioned it out earlier, like a washing machine and smart TVs, all will be making use of a controllers. So as far as a washing machine, as I mentioned it out earlier, in microwave oven, place the food inside this microwave oven. After some durations, it will be automatically, it will get heated up or it can be able to cook up and it will be giving it out as an output. So this is a thing which we will be doing and we call it out as a embedded systems. So these are some of the examples here. So now this is some statistics. So here the thing is totally 6 billion plus devices shipped annually worldwide in 2025. In 2025 we are having like a more than, as per the data from 2025, we are having more than 6 billion plus devices have been shipped, embedded devices. Now for IoT instance, Internet of Things. So Internet of Things, connected IoTs devices globally powered by embedded systems. 75 billion plus devices made it out as an impact, cross-industry impact have been made by making use of an embedded system. Obviously, when you are going to deal with Internet of Things, IoT, obviously we will be having a system will be coming into the picture. Without embedded systems, there will be no internet of things. So that topic is a separate topic. So next thing is 150 billion plus market size. It is keep on growing as per the valuation estimated. So we are having very good opportunities for young engineers, particularly in the embedded engineers domain. Embedded system engineers are most wanted engineers as per as 2026. As per the 2026 data, embedded engineers are having very good scope. So these are some of the statistics about the embedded systems. So in this system, what does it constitute? Actually, if you take it out embedded systems, it can be having like a microcontroller, microcontroller or microprocessor. So what makes the difference between microcontroller and microprocessor? For example, microcontroller in the sense it can combine all the devices, like it will be having like a ADC, EACs, everything will be there in a one single chip. As far as the processor is concerned, we will be having only the processor chip. For example, if you take it out like Intel processors, AMD Ryzen, these are all processors. As far as the controllers are concerned, we'll be having like 8051 controllers like that we are having. So it is going to perform a specific task. So we'll be having sensors and actuators. So obviously, when I want to sense the physical world, we need some sensors. So then only we can able to detect and we can able to do it some tasks. So for that, that is called as actuators. So for sensing, we'll be making use of sensors, and it has to do something. For that, we need actuators. For example, your motors. That itself is going to act like it's a actuator. Then we'll be having like a memory. So we'll be having like different types of memories will be there. As far as the microcontroller is concerned, when compared to microprocessors, it will be having less memories, because here we'll be having like what we call it as a flash memory is there, where we'll be able to store your programs. Then we'll be having like SRAM will be there, that is we will be making use of runtime data, like variables will be stored in this static RAM. Triple EEPROM, electrically erasable programmable read-only memory. It is a non-volatile data. Size is usually it is been limited. So this is non-volatile. That means once the power goes off, we can't erase the data. Actively it will be there. So as far as this one is concerned, another one embedded system is there. That is what we call it out as a real-time operating systems. So here in this embedded system, we need to make all the decisions, everything in a quick response. Quickly we need to make the responses. For example, if you take it out a car, as I mentioned, a car has different ECUs. Suddenly an accident happens. So what that has to do? Accident, it has happened. Automatically this airbag should have to open it out. So for making the airbag to open, it is having some controller. It has to get the real-time data, then it has to respond immediately. So that is what we call it out as a real-time operating systems. So it has to do some specific task at a specific period of time. That is what we call it out as a real-time operating systems. There is one software is there that is called as VxWorks is there. This is RTAS, real-time operating systems. Then apart from that, we are having like a communication interfaces. When I want to communicate with the different devices, we'll be having like a communication interface like UART, Universal Asynchronous Receiver Transmitter, then SPA serial peripheral interface, I2C inter-integrated connector, then control area network. What are these things? These are all communication interfaces. For example, if I want to connect my RFID, you might have observed about RFID tag. When you are going to any all highways, when you are going, automatically it is detecting that particularly the tag. So it's making use of the RFID tag reader. So that is RFID tag reader is nothing but when you want to use it out, we have to make use of some protocols. That protocol is nothing but serial peripheral interfaces. That protocol will be making use of it. Suppose we want to connect your GPS model. So when you want to connect a GPS model, we have to make use of your SPA or UART, we have to make use of it. Suppose if you want to make use of connect your 16, that is LCD display, that is 16x2 LCD display, then we will be making use of the I2C protocols, will be making use of it. So for example, in automotive, again I want to mention it out, in automotive when ECUs want to communicate with each other, they will be making use of some other protocol. That protocol is nothing but LAN, CAN, LIN, all these protocols will be coming under the communication interfaces. So it is nothing but it has to communicate with other devices through a particular set of instructions. Then only can able to make it out the communications. Otherwise, communication can't able to happen between the devices. Then finally, the power supply. as far as the power supply is concerned, we can able to utilize less power in this case, because it is going to operate with the less power requirement, unless like in your processes, because it is going to run on limited power. Power management is an important factor as far as designing the embedded system is concerned. So obviously these are the things that constitute a embedded system. So microcontroller, sensors, actuators, then memory and communication interfaces, all these things, power supplies, all these things constitute a embedded system. Then what is the difference between the embedded system and the general purpose computers? In the sense, first thing we need to know about the purpose. It is going to do a specific task. As far as general purpose is concerned, it's going to do a multiple tasks. That is what we are seeing it out daily. In a computer, we can able to perform we can able to do any task at a time. But if you take it out a controller to a particular thing, for example, if I want a microwave, in the sense, it is going to make it out to a food for stipulated amount of time. That is the example. It is going to do a specific task. So here the resources are less constrained, that is, it is limited RAM size is there, but as far as storage is concerned, we'll be having in gigabytes and terabytes of data will be available. So in these cases, here we will be having limited resources, like we'll be having like program memories like 32 kilobytes, and we'll be having like a RAM, static RAM will be with around some 8 to 10 kilobytes, like that we'll be having in terms of bytes. So real time, it is can able to operate in real time with strict timing requirements. As I mentioned it out, if it is an accident happens, it has to quickly respond to the automotive is concerned. So obviously here it has been strict with the timing requirements. Then power is concerned, it will be making use of low power consumption. So but as far as the general purpose computers are concerned, it will be requiring high AC power is concerned. Even it can able to be operated by making use of the batteries. So reliability wise, it is deterministic. This is what it is going to do. So this time, within the specific time, this is what it is going to happen. But here it is not like that. In case of general purpose, it can able to do any process or operations at a time. So examples, as I mentioned it out, like a thermostat, right? For example, in a particular time, I need to switch on the AC. So it will be automatically, it will be opening the AC, switching on and off, right? So thermostat, ABS and controllers. So anti-lock braking systems, pacemakers in the sense, it has to make the signals, electric pulses should have to be given at a stipulated time. So the microseconds it has to keep on giving the electric signals. So as far as the general purpose computers are concerned, we'll be making use of laptops, desktops and servers, right? These are some of the sensors. This is not limited to these sensors. You may be asking, you may be having a doubt like whether these are the sensors we have to make use of it for the embedded systems. Not limited. These are some of the sensors we can able to make use of it. For example, temperature sensors, we can able to sense the what is that? We can able to sense the temperatures. That is the thermostats is concerned. LDR, light dependent resistors, then proximity sensors, which can able to detect about the object is nearby. For example, in your reverse car parking, we'll be making use of this type of proximity sensors, which will know about what is the distance it has been there. Motion PIR sensors, if a person is standing or moving, if the person is going out, then automatically it switches off the light. This type of sensors, accelerometers and gyroscopes. For example, in your mobile phones, will be when we are tilt your phones, automatically it will be changing from portrait to landscape. That is automatically it will be changing. That is nothing but this gyroscope will be making use of it. As far as the gyroscope is concerned, we'll be making use of, for example, in your drones and wearables, and particularly for this virtual reality, augmented reality, virtual reality, there we'll be making use of the gyroscope sensors, will be making use of it. So then another thing is like moisture sensors, rain sensors, like that we are having different types of sensors are there. So now it comes to the Arduino part, right? So Arduino is nothing but it is like a rapid development board. If I want to make a simple project, right, instead of going for creating a new board, it is already been available as a development board. We have to make use of that board. Based on that, we can able to do some projects. That is what we call it out as a Arduino. That is a rapid prototyping board. So Arduino Uno is one of the rapid development prototype board, right? So here they are being making use of a chip called Atmega 328 chip they are using. It is running at 16 megahertz clock. That is the clock rate at which it is been running. The important thing is here it is open source. Open source in the sense it can be able to make use of it both. That means the software and hardware, both all the things details are available in the website itself. If we go to the website, we can able to get the schematics, we can able to get about the hardware details, and we can able to get about the programming details. So it is having a specialized software called Arduino IDE, Integrated Development Environment. So there we can able to take the open software and can able to modify it out, and we can be able to make use of it. So it is a beginner friendly thing. So we can able to make use of so many projects. We can able to use it. We can able to do many projects along with different libraries. We can able to do it. So it is having like a analog, PWM and serial communication out of the box. So here just one thing is, here we are having this Arduino rapid prototyping development board has power pins of 5 volt and 3.3 volt is available. Analog pins generally for reading the signals from your temperature sensors or light sensors like LDRs, then sound sensors, then it will be going directly to the analog inputs. Then digital outputs will be able to have some 14 pins are there. D0 to D13 will be having 14 pins are there. So in that 14 pins we can able to connect the sensors, whichever it is going to give it out as a digital input or going to give it out as a digital output. The tilted symbol, next one is the tilted symbols will be there, that is called as a PWM pins. So this is mainly used for pulse width modulation. If you change the duty cycle, then obviously for example, if I want to change the motor speed, or PWM pins and communication pins, we will be having like a UART. That's what I mentioned it out about communication interface, like UART, SPI, I2C will be there. So this is a PWM pins. For example, if I want to control the speed of the motor and if you want to control the brightness of the LED, then we will be making use of these pins, analog pins. So for setting up, we will be making use of this Arduino IDE. So after you can be able to download the software Arduino IDE from the website. So you just install this one. After installing, you have to select the board Arduino Uno, and important thing is you have to go to the tools and you have to select the port, select the correct port, right? Otherwise it will be creating a error will be coming. Then editory area is there. Then we'll be having a serial monitor will be there, and verify button, upload button on the toolbar is available. So the thing is, first program you can write a blink program. It is going to have like a pin number 13. Generally we will be making use of blinking LED. It is like a program. Just we want to make the LED to glow, right? For that to blink. So we are be making use of a pin number 13, and you have to make it out. You have to use setup and run. Setup, it runs once when the board powers on. Once it will be running it out. Loop, it will be continuously, it will be repeating. That is what it is going to happen. So for example, this is the simple program which has the pin number 13 is been defined as an output, and pin number 13 is being made high. Then afterwards we have to delay it for 1000 millisecond for 1 second. Then afterwards we are making it to go low. So then we are going to monitor this data. We can able to make use of serial monitor through which we can able to observe, or physically if you want to check it out in the sense, you have to connect one LED to the pin number 13 and you can able to see the LED pin is glowing or not. These are the key takeaways. So what we learned, this is embedded systems. It is a dedicated computer which will be performing a specific task. So Arduino Uno board which has some 14 pins, and it is going to have some 6 analog pins, A0 to A5, and 6 PWM pins, and it has works at a Atmega 328P controller is there. It works at a clock rate of 16 MHz. Arduino IDE is being used for programming the controller, and first program what we saw is blinking. So this is what we are concluding the session. So thank you all. If you are having any queries, please contact me in this mail ID muralidar@jjcet.ac.in. Thank you all.